Thank you very much. The answer to how I manage that with 4 kids is magic, and that magic is my wife. All right. So the topic is fighting test flakiness with time machines. So I have a question for you for the very beginning. Would you like to travel back in time? Raise your hands. Who would like to travel back in time? All right. What would you like to do if you would travel back in time?
Maybe change something about the project.
Change the project that you're working on? That's a very software development answer. Who else? We got anyone else who raised their hand? You can shout out.
Buy some bitcoins.
Buy some bitcoins. All right. those are great answers. For me, actually, I would go to my own life and apply the knowledge that I have today. So yeah, maybe buy some bitcoins, or like when I'm arguing with my brother and I have a clever comeback, but like 3 months later, I would want to use that, So like there you go. The point is that I'm trying to make is that we learn from the past. We are now at TestJS Summit, and you might ask, like, what does this time traveling have to do with anything? It's that we learn from the past. If we can time travel and apply the knowledge we have today, we can do better. A lot of testing is actually the process of learning from the past. For example, if you write a bug report, you document the things that happened, you try to look into the past, and so you can try to fix them. With test automation, we use all kinds of different data and see traces of the test run. We, again, look into the past and apply that knowledge. If you are doing SRE, you probably have conducted like a post-mortem meeting after a incident. And all that is basically learning from the past. All right, so now the question. How to learn from the past? If you think about it, we only have like a couple of options. We can either use our own memories, try to recall what has happened. We can talk to someone who witnessed something of interest. We can try again. We can try to recreate the past. Or we can use a time machine. And we do actually have time machines, and I'm going to be talking about them. And all of these ways of traveling into the past are good, but they have some flaws. So let's go to the first one, using your memory. So if you're writing a bug report, I recently asked on LinkedIn, how do you write a bug report? And these are like the different answers that came in, what the bug report should do. And it's a lot. And I haven't even included everything. It's like descriptions, steps to reproduce, screenshots, videos, desired behavior, etc., etc. The biggest problem is that even with all of this information, it might still not be enough. Which leads me to the other thing, talking to someone, especially this happens in a team where the testing and fixing the bug or reproducing and fixing the bug is distributed among many different people or more people. And there's a communication bridge we need to create, and communication is hard. It's no easy task, and even in real life, if you want to talk to someone, let alone if you want to try to convey complex information, and this often leads to an issue which many of us already had. Could not replicate, moving to backlog. Anyone has experienced this? Yeah? Okay, then it's not just me. And it can be so annoying, for all parties involved. Oftentimes, you can have amazingly smart people, and it would still happen. A couple of hands raised here, you are all smart people, and it has happened to you. And by no fault of your own, you might lack information, you might lack clear communication, you might lack technical knowledge, and again, by no fault of your own, there's always something that can get in the way of finding the issue and then fixing the issue and learning from the past, learning what happened. So again, talking to someone overall is great, but when you want to learn from the past, but also has some flaws. So let's move on to the next point. Trying again, that's another way of how we can learn from the past. AKA debugging, AKA trying to recreate. the past. Now, we all done debugging. We know how difficult it can be. You can use local development. You can use debugger or print statements. By the way, print statements or debugger? Print statements, raise your hand. OK, good. Debugger. OK, we got some fancy people. All right. Yeah. Everything and all that you do in hopes of recreating the issue, trying to replicate. Maybe you try again and again and again. In the context of test automation, it might be rerunning the test again. Walmir had a nice demonstration of how you can sort of burn in the test and try again to reproduce sort of like a flaky test or something like that. And this brings me to like the final thing of how we can learn from the past, and that's time machines. I personally find time machines the most exciting, especially in context of test automation. Time machines can reveal subtleties that would otherwise be hidden from us. For example, time machines can show us DOM snapshots. So this is a screenshot of a Cypress test that is failing. We have an e-commerce demo application where we want to buy this fancy sneaker. And the test, basically, we click a button, add to cart, and we want to see a message like successfully added to cart. Now, this test is failing, but we can use the time machine. We can travel back in time and look at the click event. And what we can see in this short video is that when we clicked on the button, there was this counter that shows number 0. So we were actually trying to purchase 0 sneakers. And this kind of information, this snapshot from the point where the click was made, can be really, really useful. So this is the test. And we can now change that test, use that information from time traveling, and fix our test. We can take the input and say, oh, it should not have value of 0. Only then we would continue on and click on this. We can also take a look at network requests, right? This is, again, the same Cypress test. The usual problem with these API calls is that they're asynchronous, right? We don't really wait for the response. They don't block us from doing stuff on the page. So maybe we clicked too early. That's actually exactly what happened in this test. So what Cypress does with these XIJAR requests is that it will take a snapshot at the request time, and it will take a snapshot at the response time. So we here are zooming in on the check availability endpoint. So there's the endpoint that checks whether the sneakers are available, and then we, at some point, click on the button. Now, the response snapshot, you can see that we see the message failed to add product to the cart. And this demonstrates that we clicked on the add to cart button before the response from this check availability endpoint came in. And this, again, is an information from the time machine, from the timeline, that we can use to make our test more stable. For example, in Cypress, we can use intercept to catch a certain API call and then wait for that to happen to give us the response and only then move on to the next test. Here's another thing. Here's Playwright. This is a trace viewer that provides us with action observability. Not sure how well you can see that, but I'm pointing to this lower part over here. This is all the information, all the logs of what happens when you try to click on something. So you can see that we are checking whether the element that we're trying to click on is available, it's not disabled, it's not covered by anything else, etc. And because our test is actually failing on the visibility check, right? We want to see a message appear, and it's not there. We might be trying to look back and trying to look on the commands that were before, so we can sort of rule out that and that there's a problem with the click event or something like that. And again, this helps us sort of narrow down the problems, and we can see what's going on with our test. We can see what's wrong. Another example, we have the console outputs. In this case, test flakiness may be pointing to a real issue, and that's important. And the real issue can be intermittent, but if we have the logs from our application, the console logs, this can help us a lot. Another example in the Playwright's time machine is the test definition. It helps us specifically if we're dealing with like more complex scenarios. And yeah, so we got all of these options, which sort of leads me to reiterate on a point that I made earlier. Time machines are cool. All right. But there's one problem that I have been thinking about a lot, especially in relation to test flakiness and time machines. I recently asked people on LinkedIn the following question. If your app and server were completely flake-free, what do you think that would happen to your tests? Would they be less flaky, as flaky as before, more flaky, or something else? The overwhelming majority said that their tests would become less flaky. And perhaps no one has put it better than Corey House over here. Adding automated tests to a flaky app leads to flaky tests. And I totally agree. So we talked a lot about test flakiness. We're at TestJS Summit. But I don't think we talk that often about app flakiness, and we need to talk about it. So let's go back to the solution from before, where I would intercept the API call. Something does not sit right with this test. Our users don't wait for API endpoints. And they can easily run into the same problem as our tests do because they may have a slower network or may have a slower CPU or whatever, which is not good. So all of the ways of how we can learn from the past, we can always find some foot gun, right? We might have not enough information, we're not able to replicate. Debugging is hard and frustrating, and also with the time machines, we're ignoring the app. So what's the solution then? Well, I think I might have one, and I want to show it to you. So 3 months ago, I joined a company called Replay.io. You might have heard about them. And I believe it solves these problems. And you might call me biased, I know, because I work for Replay, but I became a fan before I joined the company. So I think, well, you be the judge of that. All right, so let me explain how it works. The principle is kind of simple. We have built a time-traveling debugger, and the idea is that you create a recording of your application, and then you open that recording in the DevTools. And you can create a recording in many ways. You can do that manually, so we have our browser that you can just open, hit the record button, and then start interacting with your application. We have a CLI that will open the browser for you, so you can, again, create that recording manually, and close the browser, and you have a recording available to you. Or, since it is a browser, you can actually use it with Cypress, and the npx Cypress run browser replay Chromium would be how you would run that. And then npx Playwright test, this would be the setup for replay Chromium. By the way, these are all in our docs, so you can check those out. Also, we support WebDriver, IO, Puppeteer, or even Selenium. So yeah, that's the recording part, right? So what do we do then with the recording? Actually, let me show you the debugging part of the experience. I'm going to close my presentation, switch to mirroring the display, and hopefully we can move on. All right, this seems to be working. All right, so here I have a recording of the same application that I've been showing to you. So we have this e-commerce store, and down below here we have a timeline, and I can play this like a video. Let me play that from the beginning. Right, so we open the app, and you can see me sort of iterating on the counter, hitting 1, 2, 3, etc. That's where the recording ends. On the left side over here, you see that we have this click event. So it's not only a video, it's actually a recording of the interaction. Now, what we can do here is to click on this blue button over here, where we can jump to code, which will switch me to this DevTools panel, and we can see the code that has been executed when we clicked on that plus button over here in the application. Now, this is a collaborative tool. So if you are not on the test automation side, maybe you are a QA engineer on an exploratory session, and you want to hand that over to the developer so that they will deal with that, you can sort of just go ahead and add a comment, like this is not a right image, or hello, or whatever. This way, they cannot tell you they are not able to reproduce it, because you have that recording, you have the proof, and you actually have the code inside here. So what that means is that if you look over here, the jump to code has taken me into the component that was actually triggered when I was clicking on that plus button. Now, here on the left, there's this gutter, and this number 10 that you see over here is actually telling me how many times this line of code was actually hit. So that's already useful information. It sort of works like code coverage, where you can see which lines of code were hit and which ones were not. And what you can do is you can click on this plus symbol, and on the console, you can now see all of the instances where when that line of code was called. So there's this default text, quantity, control, and the line number 9. But what I can do to get some insight is to print out for some variable. So for example, this quantity over here. And now I can see the quantity variable that has been passed into this setQuantity function, and I can see how that changed over time. And I can rewind back or go forward. Now, there are some people that are using debugger. Well, you can use debugger in here, not only print statements. So I added a breakpoint by clicking on this number 9, and now I can go back and debug this, right? So let's go to the timeline. Let's look at this scopes panel over here. Wait, actually, let's jump into the breakpoint. We got the quantity 2, so we can move forward, or we can move backward. Wait, let me wait for this to load. Now we got quantity 3. Let's move on backwards to quantity 2. So if you have used breakpoints and debugger, you might have accidentally clicked one more time that was needed. I guess everyone has felt that. If you have that recording and you're debugging the recording, you can move back and forth. Now, usually when you debug, right, the way you do that is that you sort of modify your code. You add a console log somewhere or add that debugger statement in your code, and then you run that and try to replicate that and hope that you could get to that issue. And you need to do that several times. With replay, if you have that recording, you can actually just catch the bug once, and then add those print statements and whatever anytime you need. Also, if you want to share that, you can click on share button and send it to whoever needs to fix that. All right. One more thing I want to show you. I mentioned that the recording, you do that with our replay browser. And you can hook up the browser to your test suite. So if you are using Playwright or Cypress, you can just create your recordings automatically. Let's now move on to this recording that I have made with the Cypress test. Now, in this one, what I did is that I ran my test and it failed the first time, then it failed the second time, and then finally it was passing. So I can now compare my failing test and my passing test. If I go to the failing test and take a look at this click, again, I have this jump to code function. So I can see what my Cypress test was clicking on and what part of code was executed as the Cypress did that. And you can see here that it has called this add to cart function, which calls the add to cart API. And in the body, we're sending the quantity that's over here. Now, the quantity is a state that's 0 by default, and the state is mutated over here in the set quantity, and we are setting that after we get the response from the check availability. So if we add a couple of print statements here, I'm actually out of time, so I need to make it quick. I'll set send to server, like this. We can see what has been sent to server, right? We've been sending the number 0. If I print out this data, QTI, and print out availability, I can see what has come from the server, right? And this is a timeline, so I can actually see in what order was this made. So we're sending number 0, and I'm not sure why this is not loading, but at least you can see we're live. All right, now if we take a look at the whole test, I can see the difference between the passing instance and the failing instance, which is now loading. Oh yeah, all right. So here we have the failed attempt, and then finally we have the passing attempt where we finally are sending the information, ordering 1 sneaker and not 0 sneakers. All right, the time is blinking at me, so I need to I need to finish this talk. Basically, my point over here is that something is happening in code. We have some asynchronous operations that are not playing well with our test. If we were to disable this add to cart button while we have the quantity set to 0, we would actually fix all of the issues with our tests, because Cypress and Playwright, they check whether the button we want to click on is actually actionable. So we don't have to wait for the intercept, we don't have to assert that the number is not 0. The tests would magically just pass without any modification. Yeah, back to my presentation. I have final 2 slides where I want to demonstrate that if you basically replay is solving the not enough information problem. If you can replicate it once, you have enough information. Also, the debugging. If you just record whatever happened, you can add a print statement, debugger. We have Redux, React DevTools, Redux state, etc. And most importantly, we're not ignoring the app we are testing, which I think is a great mistake that is being done when we do the end-to-end testing and when we are dealing with test flakiness. All right, that's my talk. Thank you very much. Come talk to us. We have a booth, and thank you.